Okay, and we are almost ready to go. I need to clip this thing and there we go. Nope. Oh, all right. Last session of the conference. Yay? Kinda, sorta. All right. I'll try to wake you up a little bit. It's going to be fun. Okay, welcome to Coding Fast and Slow, applying Kahneman's insight to improve developer practices and efficiency, which is a mouthful to say. It's going to be a fun talk. Basically, that's kind of what I want to say. All right. Who heard about Professor Daniel Kahneman? Come on, people. All right, so you're in for a treat. Professor Daniel Kahneman was, unfortunately, he died this year, one of the most important researchers in the 20th and the 21st centuries. He is a Nobel Prize winner in economics in 2002. And the interesting part of him winning the Nobel Prize in economics is that he is not an economist. Basically, this is the nomination for having integrated insights from psychological research into economic science, especially concerning human judgment and decision-making under uncertainty. Professor Kahneman was a professor in behavioral psychology. He studied how people behave. How professor in behavioral psychology wins Nobel Prize in economics? It goes like this. If you ever took any class in economics, Economics 101 goes, people are rational and this is why markets work. And this is something that you are very familiar with, supply and demand. You will buy more of what's cheap, you will buy less of what's expensive. If there is plentiful of something, the prices goes down. If there is rarity, the price goes up, right? Makes sense to everybody. We apply it on our daily basis when we buy stuff. And this is how economics is taught everywhere until today. Professor Kahneman goes like, nope, people aren't rational. And here are 50 years of study by me and my colleagues that prove that people are not rational. Oh wow, they really aren't. It probably has a profound effect on economics. Here's a Nobel Prize for ya. And this is how it goes. And the funny thing is, if you study economics now, they will tell you people are rational, and this is why the markets work. Both of them are true. People are rational, and this is why the markets work. They're also highly irrational, and it has effects on economics. So let's talk about the irrational side of people and how it affects not economics, but software engineering. If you want to read one book by Professor Kahneman, that's the book. It's called Thinking Fast and Slow, and this is why this talk is called Coding Fast and Slow. And this is a summary of most of his research. I think since that book there was only one more or maybe two, and they are very, very hard to read and comprehend, as opposite to this one. This one is layman terms, and it's exciting and it's amazing. It's really one of my most common recommendations of books. There are a lot of recommendations of books in this talk. All of them are my favorites. This is definitely one of them. Okay, so an example of how people are irrational. I need you to answer fast without thinking. A bat and a ball costs $1.10 in total. The bat costs $1 more than a ball. How much does the ball cost? Shout. 10 cents. If you are like most of people, and this is a phrase that you will find a lot in Professor Kahneman's book. if you are like most of the people, the first thought that will come to your mouth will be 10 cents. And 10 cents is an absolutely wrong answer, and you will understand it if you think about it just a little longer. 10 cents plus $1, and we said that a baht is more expensive than $1. $1.10, it's $1.20. This is the bet, this is the ball, this is the total. So what is the correct answer? The correct answer is obviously 5 cents. Now, we're software engineers, we know like whatever, third grade math. All of us. And we can definitely figure it out. The reason why, if you are like most of the people, you shouted 10 cents, is because this cognitive something that forced us to shout a wrong answer before we actually thought about the right one. My name is Baruch Sadogursky. I'm at JBaruch everywhere, like on the internets, and I'm a developer productivity advocate with a company called Gradle that you, I wouldn't say might know because this is a Java conference, that you know and love because of the Gradle build tool. But we do much more than build tool, and our mission is to improve developer productivity through engineering. And this is why I'm talking to you today about psychology of all things. Makes perfect sense. My perfect journey is I started as a developer 20 years ago, and then I went all DevOps with another company that you know and love called JFrog. It's been there for the longest time, and now for a couple of years I'm with Gradle dealing with developer productivity engineering, #DPE. I wrote a couple of books, DevOps Tools for Java Developers, which is the DevOps and Java, and again, everything you know and love, and Liquid Software, which is a visionary book of how we should release software in the future. Well, now as well, a little bit, I guess. The most important slide of this talk is this one. If you go to speaking.jbaruch, you will find the slides already there, the video recorded right now, all the links for everything I mentioned, all the books, including obviously Thinking Fast and Slow, and everything else is there. And to make it easy to remember where to go, it's conveniently on the bottom of every slide, together with some social hashtags and accounts for you to mention when you praise this talk, because it's absolutely awesome. Right, so as I mentioned, all you need to remember is this. Oh, look at that, I can do this. Yeah, here we go, speaking.jbaruch. Okay, so why? What happened for most of us with this stupid 10 cents mistake? The reason why we made this mistake is because our brain has two systems, as Professor Kahneman put it. There is system one, which is very fast, very intuitive, automatic, emotional, and cheap and eager to answer, to work. And this is exactly what was in play when we said 10 cents without thinking. It was very fast. Intuitive is pattern recognition. In this problem that I put to you, there was easily recognizable pattern. Something costs $1.10 and something else costs $1 less. This is a pattern that we know from first grade, and this is why our intuition immediately jumped in shouting 10 cents. This is the intuitive part. Automatic, we didn't consider answering something else. Emotional, it felt good to know the answer immediately. We were like, of course we know the answer, it does feel good. And cheap and eager to jump, we didn't apply any effort for this answer, and we delivered the answer straight away. But there is also another system, conveniently called System 2 by Professor Kahneman. And this System 2 is exactly the opposite. It's slow, it's analytical, it's controlled, logical, and it's expensive and lazy. Now, when I told you that the answer was wrong, you forced yourself to use System 2. You took your time to really read the question. You analyzed it in a controlled fashion without jumping to conclusions. And you immediately found what was wrong with it using logic, but it took you effort. So those are the two systems, and this example just showed you how they are different. Basically, what's going to happen, right? System 1 goes like, hey, I recognize the pattern. And System 2 like, wait a second, let's think about it. Now when you know how I'm going to treat you throughout, how I'm going to trick you throughout this talk to force you to jump to conclusions with System 1, now you've been warned and you are going to say, wait a second, it's a tricky question. There is something here that we need System 2 for, and this is what is going to happen. Let's see how good you are in actually doing that. Right, so this is a pretty trivial Java code that has a pretty obvious bug. It's not like super obvious, but it's nothing complicated. I bet if you look at it for like 30 seconds, I will start hearing from you what's wrong with this code. It's like Java puzzlers, if you remember. But no tricky question. This is, huh? Okay. No null checks? Nah, that's okay. I mean, that's true, but it's not what's obviously wrong here. I know it's the last session of the conference, I know. Yeah, go ahead, just shout it.
The or should be and.
The or should be and. Why?
Because when it says line starts with pound sign, or line starts with // that would be appropriate if we were testing if it is a comment.
But we have a no here.
Yeah, but we've negated both of them, and so the operator has to change.
It's very close. I'm looking for something very specific here. But it's right there. I will limit it even more. It's right here.
Yeah.
What about it?
It should be and.
No. Why do we have two lines? What does it mean? One line, what does it mean? And what's the difference between them?
One line is bitwise, 2 lines is...
No. Jeez, people, you don't know Java. Come on. Go back to school. Okay, Victor. Why there are 2 lines? What is the difference between 2 and 1?
If the first one is true, I mean, it does not go check the second.
Thank you very much. This is a lazy or. Lazy or means that if this is true, the second one won't even be evaluated. And in this case, if the line starts with hash, it won't even check the other condition. Now, there are 2 solutions for that. We can only use one line, or we can do what this gentleman here said, convert it to and without the or. But yeah, no, I'm surprised that you didn't know about lazy or. And it's the same thing, right? You can have 1 ampersand or 2. 1 ampersand will be always evaluate both, and 2 ampersands will be lazy if the first one is false, is true, don't check the second one, right? Okay, never mind. We managed, kinda, sorta, group thing. Okay, we managed. Okay. Now, what we're gonna do is, I'm going to show you really quickly, in a quick succession, words in different colors. Now, what I need you to do is to shout the word and not the color of the word. Really fast. Ready? Let's do it.
Red, green, yellow, brown, orange.
All right. So the reason why you succeeded is because I warned you I'm going to trick you. If I didn't do it, and you like the most of the people, after our little mental exercise with Java, System 1 would have a terribly hard time to manage to read the word instead of saying the color. Because color recognition is System 1, reading is, well, for adults it's also System 1, but it's a little bit harder. And because you worked so hard in trying to solve what's wrong with our Java code, engaging System 1 became harder. And that's because we have mental fuel. Now, there is a great scientific paper called Attention Capacity Limits in Perception, a Cellular Metabolism Account. This is how it looks like, and I have no idea what it means. I tried to read it, I understood maybe 5%. I have no idea. So obviously, you know, ChatGPT. Explain the paper Attention Capacity Limits in Perception and Cellular Metabolism Account to me, Barney style, where's Victor? Barney style, and in one paragraph or less. So Barney style, it's like 4 or 5 years old, right? This is what it comes to, and basically it says your brain is like a smartphone battery. And it draws as you use apps, and then you have fixed amount of energy for your tasks, like the battery has limited amount of juice, and when you do something that needs a lot of focus, like running power, when you use your System 2, it uses more power, and then you need to close apps to save battery, and then you need to sleep to recharge. Basically, that's the idea. Now, we always knew that, right? None of that in use for us. But they actually managed to find substance in the brain, which is this battery, which is pretty amazing, right? It's something like BNRS and OXCCO, whatever that means. But basically, cellular metabolism is your mental fuel, and it's a finite energy supply. And the most fascinating thing is that it has an energy saving mode. And the energy saving mode is your System 2 shuts down. System 2 is a very energy efficient, a very energy hungry mode. And it shuts down when you don't have enough fuel. Now, which system do we use for coding? What do you say? Who thinks we use System 1 for coding? Who thinks we use System 2 for coding? Yeah, I mean, it's right here, right? I mean, we can write code on System 1. It's like we can read on System 1. But if we want to do some meaningful work, it will probably be something here. I guess, like what, a year from now, the System 1 coding will be pretty much covered by AI. Whatever we can spill on autopilot will be done by Copilot, basically. So we will leave here for coding, which is very exciting. Right, so this is mostly now, but definitely in the future will be the software engineering right there. Okay, another book. Hey, this is a book called Flow by Mihai. He came up with the term of flow that all of us experience sometimes when we are in the zone writing code. This is how he describes it. A state of effortless concentration so deep that people lose their sense of time, themselves, and their problems. Who experienced flow when writing code? Everybody. Obviously, this is why we write code. This is the most fun you can get. The interesting word here that does the heavy lifting for our purposes of our talk is effortless. Now, this is quite extraordinary because we write code with System 2. We established that. System 2 is power hungry. We established that. But then there is a cheat. We can write code without wasting mental fuel. Now, this is where our analogy with smartphone breaks, because in the physical world of chemicals, this cannot happen. There is no cheat in your smartphone which allows you to use power-hungry apps without draining power, or with draining very little power, but in your brain there is. The flow is such a state, and this is why it's a miracle, and it's very, very precious. Keep that in mind. The opposite of flow is deliberate attention control. Attention control is very expensive in terms of mental fuel. Yeah, another book. Gloria Mark. Gloria Mark, professor, studies attention for decades. Just recently, this year, she published a book called Attention Span, which basically summarizes 25 years of her research in the field. And it's great for us because otherwise we would have to read more scientific papers. I don't want to do that. Instead, we have a great book. Couple of highlights from this book that are promised gonna blow your mind. Average person, remember, if you are like most of the people, you check your email 77 times a day. I mean, we all knew that we do it a lot. How many of you recognize that it's 77 times? That's mind-boggling. Here's another one. Our attention span has dwindled to 47 seconds on every screen. Again, we know that we multitasking by jumping around through windows and screens, but 47 seconds. And now, the most important in our context is it takes 25 minutes to return focus to a task after interruption. Remember this number, 25 minutes. We're going to get back to it because it's terrible. Yay, more code. Okay, what's wrong with this code? Yeah, really? Yeah, you just hard time seeing it? Yeah. Okay, sorry about that. It's just the projector is very dark. I mean, if it's that bad, we can just skip. Tell me, do you see it, or should we just skip it? You can read it barely. Okay.
You already have the discount. Why would you calculate?
No, it's actually, yeah. So you say that, what are we doing?
Calculating the discount from total price.
Calculating the discount from total price. So we have the price, and then we have the discount, and then we print the final price after discount is final price.
Just getting the percentage. You said like if you have $30 discount, then
It's a percentage.
Yeah, no, it's fine. Yeah.
Percentage points, not a value between.
Yeah.
But price times discount.
Victor, stop switching between screens. Focus.
It's the mathematical problem there, like like that BODMAS kind of thing. take precedence?
Well, there is no precedence between multiplying and division, but the problem is here, and it's kind of, yeah, it's not a bug. Let's put it that way. There is something wrong with the code which doesn't elevate to a bug, but it's definitely like a smell.
85% it says fine. Discount is 85. Percentage is placed was wrong.
Okay, I will.
Should it be 100.0?
It's exactly there. 100.0 is not a problem because it will convert it to double, but you don't use double for currency. You never use double for currency for many reasons. For starters, if it wouldn't be that nice 15 and 100, it will be on 103.5 and 8%. This is going to be a very ugly string. But more importantly, the rounding of double, your accountants won't like you one tiny bit. Don't use double for currency, instead use big decimal. Cool. All right, we figured that out. You thought really hard. System to engaged, fuel, mental fuel, drained. Now let's count triangles. How many triangles?
15. Oh shit.
Yeah. Oh shit. Yeah. Because there are a lot. Yeah.
13.
Okay, who cares? Like, if I remember correctly, it's 18. It's in my speaker notes, which are covered, so I have no idea. I think it's 18. Never mind. Back to code. It's not the same. No, it's not the same.
Well, we have a double. If you have a double, it should be a big decimal.
Yeah, no, that's true, but there is another bug as well.
Okay, okay.
Yeah, no, but you're right. Yeah, but there is but we keep using double, which is a problem, but yeah.
Yeah, you're not converting your tax rate to a percent.
Mm-hmm. Yep. 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 Good job. Good job, everybody. Yes. So, again, you know it's tricky. You work really hard. Good for you. If you were relaxed and not prepared for the ambush, solving this much obvious bug, finding it, would take you much more time. And I don't know if you felt it, that you really had to concentrate more, and that's because of the stupid triangles. Triangles really knocked you off the context of code, and it was this kind of, I'll check my email while my build runs. The problem is with context switching that you deplete your fuel by context switching very, very fast. It's even worse because context switching kicks you out of your flow. And you remember, flow is the most efficient way to do work while saving fuel. So this is a loss-loss. Instead of saving fuel in the flow, you're actually wasting fuel on context switch. You need more fuel for working with context switches, but you actually have less. Yay, more scientific papers. Now this one you're gonna love. Characterizing and predicting mental fatigue during programming tasks. The big reveal, like really big one, hold to your heads. Developers are cutting corners on quality when they are tired. Boom. Completely unexpected. Who could have guessed? Scientific paper, published, reviewed, and all that. Well, when we are tired, we produce worse code, which is fine, which is obviously fine. What you would expect is when you're tired, you're like, okay, fuck it, I'll look at it tomorrow with fresh eyes. That's what the story that we tell ourselves. The problem is that we don't do that. We don't do that because we don't know where to quit. And this has been proven by science. One of the most frightening experiments of Professor Kahneman was observing parole judges when they decide whether they want to give someone parole for their sentence or not. Now, for those judges, the default decision is to deny parole. To grant parole takes mental fuel, system 2, deliberate decisions. And here is the amazing part. Fewer paroles were given before lunch and after 4 p.m. Now, this is terrifying. Think about your loved one that will be denied parole because the judge was hungry. Now, the thing here is that obviously judges don't do it on purpose. They're not evil, they're not biased, they want to do the right thing, but we don't know when to quit. They didn't realize that their lack of mental fuel affects their decisions. Granting parole needs system 2 thinking, and judges are unaware when they switch to system 1 because they are tired and go with the default of denial. This is true for us as well. Obviously, the consequences are less dramatic, but this affects everybody. When we're doing, now let's tie it all together. When we're not in the flow because of context switching, and we're wasting our mental fuel on trying to work while context switching, we deplete our mental fuel and start run on system 1. And when we write code on system 1, we get OK code. Now, if something is, when we write something and it clearly doesn't work, this is not a problem, because we know exactly that it doesn't work, we'll have tests, we're gonna fix it. But when we write code, which is working, but it's not our best, it's just an OK code, we won't be able to recognize it because we switched to system 1 because we are tired and we don't know where to quit. And here's a question for you. What do you think? Oh yeah, one objection that you might have is, hey, but intuitive is also here. Isn't intuitive is good for writing code? Isn't like kind of being in the zone when we just spill the code out and all this kind of stuff? Well, kinda. Professor Kahneman did a lot of research about intuition, because intuition is a very interesting trait of humans. How do we know what's going on? One of the examples that he used is the example of firemen that knew how to escape from the house that is burning seconds before the house collapsed. When they asked, it was like a chief of the fire brigade that commanded his firefighters to get out of the house, and a second later the house collapsed. So they asked him, they interviewed him, and they asked him, hey, how did you know to command everybody to get out? And he was like, I have no idea. It was intuition. I just knew that the house is going to collapse. And then they started to dig deeper, and they discovered that what really happened is that the chief heard the whooshing of fire changing pitch. And he knew that that means that the fire is now in the basement when there is like a less air, and it's going to burn through the floor, and the floor is going to collapse. And turns out that he knew that because he was very, very experienced. And this kind of pushed Professor Kahneman to a conclusion that was proven by a lot of research, that intuition is execute skilled responses and generate skills intuitions after adequate training. When we practice something enough, this is where it becomes intuition. Who got into their car on a weekend and find themselves by the office parking because they were preoccupied with something else? Right? You are driving by intuition because you did it so much. Hey, another book, Outliers by Malcolm Gladwell. Now, this is one of the books that drew home the message of 10,000 hours. Who knows about 10,000 hours? Most of you know that if you practice something 10,000 hours, you will be an expert. Tons of criticism. The most criticized work of Gladwell is this book. Disproven from every possible angle. Basically, what people say that this is not true. But there are tons of research in the book that actually proves that it is. So what's going on? Professor Kahneman explains. 10,000 hours of practice move some System 2 activities to System 1. Stuff like driving, the example that I gave you, golfing, tennis, music playing, and safety drill for firefighters. Now, what all those have in common? Motor skills, a lot of them, but also very, very short and repeatable feedback cycle. You do something wrong, you know exactly that you did something wrong, and you can improve next time. This is the skilled learning that can take a skill and move it from System 2 to System 1. Remember yourself at the first driving lesson? That was a lot of System 2. That was a lot of mental fuel. Now, it's like walking. You don't think about it. You don't spill any mental energy because you drive so much that this repetition with very short feedback cycle moved it into System 2, and this became your intuition. Right, here we go. Plan, execute, observe, improve. The feedback cycle works. Now, this is what we have with pattern recognition. This is exactly why we shouted 10 cents, because we did this so many times in our lives that we know exactly what to expect. And then, obviously, we need to think about it. Now, this goes exactly into OK code. The majority of you can now spill the common code that you wrote for ages in System 1 mode, right? No problem at all. You can, I don't know, start a new project with Spring Boot. Like, think about what Josh does in his presentations, how many times he does it, like, write a boot starter. You don't need System 2 for that. But this is the OK code. This is your default solutions. This is your trivial answers. This is not the great code that you can write when you think about it. So yes, you can write on intuition, it's still going to be System 1. Now, OK code is not great, but also not terrible because it works, obviously. And I have a question for you. Which do you think sucks less? Which is better, bad code or OK code? Who thinks that bad code is actually sucks less than OK code? Who thinks that OK code is better, marginally better than bad code? It's half and half, which makes sense. I'll make a case for you that OK code is much worse than bad code. You know why? Because bad code is easily recognizable. It doesn't work. It's terrible. everybody see that it's terrible, it's going to be replaced. OK code flies under the radar. It's just barely good enough to be OK, but it's actually not that great. It looks OK to us. Why? Come on, we just spoke about it. Because we're running on system 1, remember? We're tired. It looks OK to us. It looks OK to our PR reviewer. Why?
Standards and lines of code.
System 1.
Because they will review it on system 1, because they do something else on system 2. They write their own code on system 2. Your PR is going to be either, oh, OK, I fixed formatting, or looks good to me. Right? We all know that. They will review your code on system 1 because they reserve their mental fuel for their work. And it looks OK to our pipelines, because our pipelines, by definition, are built on what's called in humans intuition, the feedback cycle that is coded into them. Our pipelines are system 1. There is nothing extraordinary algorithmic expectations about what our code should look like and how they can determine good code from great code, from OK code, right? And what the result? It's an OK product. Think about our software. All of it is OK. What's not broken? Name one, except of Gradle build tool. I'm just kidding. Name one software product that is that is great, that it's not just OK. They used to be. We used to be excited about great software products. Not anymore. Most of them are OK. And this because the problem of coding in System 1 becomes more and more severe because of everything we spoke about. Lack of attention span, context switching, and all this kind of stuff. The only way to beat this problem is to invest in fuel-saving techniques. And we're going to spend our 20 minutes left in talking about how we can save mental fuel. The goal is to have enough mental fuel when we need it. Even in the end of the day, if we need to engage in System 2 activity, if we have a task that requires System 2, we have it. That's the goal. How do we do it? Time management strategies. Stuff like time blocking, Pomodoro technique. By the way, who knows Pomodoro technique? What is it about? Breaking work into 25 minutes chunks and 5 minutes rest. So how does Pomodoro technique help exactly? Doesn't it introduce context switches? Well, not really. Pomodoro technique is about concentrating at least 25 minutes on a task. If you are in the flow, if you are in the zone, go for it. Don't stop. It's about minimal 25 minutes spam, not maximum 25 minutes spam. Task batching, you put similar tasks together. And I have one advice for you, which is not a book, which is actually software, which is actually quite great, by the way, for a change. It's called Reclaim.io, and I'm a huge fan. And I spread it around to all my friends. Victor, Reclaim.io. Yes? Yes, here you go. It's amazing because it does all that. It allows you to block time for when you need to do meaningful code and batch tasks, but also it allows access. Now, what is the problem in blocking time? You are a developer, you say, you know what, fuck it, I'm not attending any minutes, I have meetings today, I just code, I blocked my entire day. Next thing, what happens? They will schedule meetings all over your block. Because they need you at those meetings. And if you're not making yourself available at any time, it's like you're available all the time. They will grab anytime they want. So Reclaim is smart enough to allow blocking time and batching tasks while still allowing access. It will prioritize stuff in a smart manner. So let's say you say, I need 3 hours a day for being in the flow, for running on system 2, writing my code 3 hours a day. Now your boss is going to say, okay, I don't know what's going on. They won't even look at your calendar. They will just slap the meeting at the time that they are available, reclaim, and it happens to be on your 3 hours block. Reclaim will be smart enough to just move your 3 hours block to a different spot. Now, the closer you get to this day and you want to plan, the more rigid your blocks become. And the day before, it won't move it anymore because, hey, you need those 3 hours in the end of the day. So I definitely recommend it. Don't have any affiliate link. Maybe I should ask for one, but I don't. But it's great. Okay. Mindfulness and cognitive practices. Sounds silly, but it works. It works because your fuel capacity in your mental battery is actually not fixed. Like in your phone, it can degrade, but not like your phone, it can actually expand. And it can expand when you invest in it, like in any other exercise. Meditation and mindfulness practices are training your fuel to mental, system to mental reserves. Single tasking, this is also about that. Workspace and interruption management, well, you know that. Workspace organization, and by that I mean noise cancelling headphones if you are in the open space, this kind of stuff. Right? Notification management, by that I mean shut them off. Prioritization techniques, put your phone away when you're writing code. You know all this stuff. Physical and mental well-being, go to gym. Victor, go to gym. Come on, I work for you here and you're on your phone. How dare you? Okay. Yeah, go to gym. It really helps. Breaks and downtime, as I mentioned, you refuel your battery when you sleep. But not only. You refuel it when you take downtime and when you really rest and not looking in your phone in your bed, obviously. Right? Yeah, when you sleep. Another couple of books. Sarah Medrick, PhD, obviously, another doctor. The Power of the Downstate and Take a Nap, Change Your Life are two very important books that will convince you to sleep. If you are young enough, you are full of bullshit, we will sleep when we are old and the sleep is for the weak and we can replace it with coffee. No, none of that is true. Instead, you need to sleep, and Sarah is going to convince you to do that when you read those books. They're really good. Caffeine nap, it's a thing. Who heard about caffeine nap? Okay, not enough. All right. When you take a nap during the day, you feel usually worse after you waken up, right? That's given, because you are like, it's not great. There is a way to overcome it. It's called caffeine nap. The way it works is you drink caffeine. It might be coffee, it might be tea, it might be your energy drink, but you shouldn't drink them, but never mind. You consume caffeine. And then you go to dark, cold, and quiet room, and you go to sleep. You set alarm for 20 minutes, and you tap into the reserves of your mental fuel. You wake up fresh because caffeine will take 20 minutes to kick in. When you have your alarm, the caffeine kicks in and you are fresh as a cucumber. It's great. And why Gradle pays me to be here? Engineering aspect of developer productivity. We can engineer less interruptions. We can engineer more system to work. We can engineer depleting less of our battery. Let's talk about how. Eliminate toil. There are tasks which you do because someone told you to do that in a very specific way. They're a waste of time, they're sucking your time, and they're sucking your soul, so don't do that. Collaborate through effective tooling. Collaboration is about a lot of time breaking someone else's focus and making them do the context switch. The less they need to pay the tax of depleting fuel, the better is for both parties. Imagine your build has failed and you think that someone else is responsible. What do? You nag them on Slack, like, hey, I think you broke the build. And they're like, okay, what's happening? And then what do? You dump a build log on them. And then like, fuck this shit. Because it's like endless stack traces upon stack traces of errors, and they have no idea what's going on. If you can send them a link to the exact description of what went wrong, it's a test failure. More so, it's a non-verification failure. It means that something in the environment is wrong and not the logic of the code. Wouldn't it be nicer for the person on the receiving end? This is an example of effective tooling. That was a scenario from Gradle to Velocity, but there are a lot of efficient tooling, effective tooling that we need to talk about. Prioritize automation and eliminating bottlenecks. Again, if you can automate something that won't bug you again, do that. Observability and proactive improvement. Do you know what's wrong in your development environment? Why you are not as productive as you want to be? If you don't know it, maybe you should find out. Outcomes over output. Build log is a great example of a lot of outcomes, or a lot of output with a tiny bit of outcomes somewhere in between, and you definitely should prefer that. And organizational mindset. Your organization should invest in providing all that. And there is one more. Foster faster feedback. This is the key for minimizing interruptions in our work as developers, and here we go. What is feedback efficiency when we write code? IDE, sub-second. You type something wrong, it will mark it red immediately. This is a feedback. You made a mistake. String with string, and you will see that you type it wrong. Build. You want it to run very fast and get feedback that your code, for example, does not compile or unit tests don't pass. CI, well, it runs minutes, maybe like up to an hour, something like that. Well, that's okay. And then production, which is obviously feedback. If your code doesn't work in production, you want to know that. But it might take hours or even days to get this feedback. Notice the pattern here. The more right we go from the developers, the longer the feedback gets. Looks like that. Reverse dependency on distance from developers. Faster, slower. Now, this is how it's supposed to behave. In reality, there is one exception. Which one doesn't work like that? Which one definitely breaks it? The build. The build is usually significantly slower than you want it to be. As we said, we want it to be bare minutes. But it's most of the time definitely not. Whose build with tests is under 1 minute? One hand, two hands. Under 5 minutes. More, under 10 minutes. Over 10 minutes. Yeah. So, should be here, but it's here. Now, we care about it because there are two types of feedback. There is asynchronous and synchronous feedback. Asynchronous feedback is your CI and your production. You don't wait for it. You do a PR, And then you will hear from it when you will hear from it. It might be an hour, CI inform you that your build has failed, or it might be a couple of days. Your users shout on Twitter that it doesn't work. That's also the feedback from production. Synchronous, like build and CI, you wait for it in the flow. You typed something, you wrote something, you try build, and then you wait to see if it succeeds or not. And then we will be pissed when it's slow, because you sit there in the flow waiting for the build and it never compiles, right? So the commit time is the difference between synchronous and asynchronous, and this is what needs to be really, really fast. And this is what can be slow. We don't care. We don't wait for it. Now, faster feedback saves mental fuel. Because speeding up your local build minimizes context switch. And then less context switch saves mental fuel. And then you run system 2 all day or whatever you need it. Now, before we get to that, remember 25 minutes? Okay. So whoever said that their build is longer than a minute, I have news for you. Your build is 25 minutes. You know why? Because you won't wait for it, and you will switch to something else. And then you will get back to it to check if it finished after 25 minutes. Even if it was 5 minutes, even if it was 10, even if it was 2. After a minute, you will do something else. And your build just became 25 minutes. Now, this is bad. So how can we engineer less context switches? First of all, we need to know how long our build is. For now, most of you just guessed. Some of you know, a lot of you don't. Managers for sure have no idea. Avoid building and testing what didn't change. We're going to talk about it in a second. Speed up what cannot be avoided, and then fight flaky tests. Next thing you know, after you fix your build, you need to make sure that it doesn't slide. So, all of this, there are a lot of techniques to do that. And unfortunately, we're out of time for me to dive into each and every one of them. But if you go to speaking.jbaruch, you will find there some pointers to what we as Gradle as a company provide. There are free services like build scans, and there are like enterprise grade software like Gradle Velocity that does each and every one of them. For example, when we talk about speed up what cannot be avoided, how about using caching extensively? Or avoiding building and testing what didn't change? How about employing AI to tell you what tests you can skip because they won't be affected by your code changes? This kind of stuff. So there is a lot of this wisdom in the tools that we provide, because this is what we try to do. Build fast or die. Thank you, Vincent. And things that you can do today. Parallel local. I have an amazing example of a demo that I won't show you because I don't have time. I have here on this machine a build that runs 2 minutes. It does stupid stuff. I turn on all the cores on this machine. This is M2, I think, MacBook Pro. And it goes from 2 minutes, 120 seconds, to 6 seconds. 20 times improvement by turning one flag in my Gradle Maven SBT Bazel build, whatever it is. 20 times. How many of you know for sure that they run parallel builds? Okay, like a third, quarter. For the rest of you, there is a potential to speed up your build 20-fold with one flag. Local caching. Again, most of you use some kind of caching. If you don't download your dependencies every build, that's a good start. but there is tons of other things to cache, including configurations, different type of tasks and whatnot, and all that can be turned on and improve your build. Remote caching is also free. You can share your caches with your team. So not only you won't rebuild what not needs to be built, but your teammates won't rebuild that as well. There is a small asterisk there because you need a node somewhere in your network and there is maintenance on it, or you can just buy it from Gradle again. Build scans. This is the hidden gem of your build environments. This is collaborate through effective tooling. This will give you all the information about your build. How did it run? Where did it fail if it did? And it allows you to share this information with everybody with an ease of a link. And you can win prizes for free if you go to speed challenge that you'll find at speaking.jbaruch to see how much faster your build can be by employing those. You can win some nice Gradle t-shirts that Vincent designed, by the way. Okay, what your company should pay for? All the books, obviously, because it's important. Top development hardware. Now you know why, right? I just gave you an example. This is a valid justification for getting the more like up-to-date whatever MacBook Pro, Ultra, Max, whatever it is, because you will run longer on System 2. It's a real deal. The velocity or similar because it provides all the goodies that we spoke about and more, and this is all. Okay, DPA University is a free university online for all things developer productivity engineering. I already mentioned the speed challenge that you get prizes for participating. DPA Handbook is basically what I just told you and much more in a book format. And DPA Summit that was yesterday in San Francisco. The keynotes are already published live. If you're curious about developer productivity engineering, what it is, how it can help, those keynotes, there are 4 keynotes, 2 hours total. You speed them up to 1.5 speed, obviously. So it's like an hour and a half of watching on your way home. Good stuff. I really recommend it. Free on Gradle YouTube. Just go and watch them. And yeah, so no, don't ask me for a discount. It's already over. But the videos are there for free. Anyway, thank you very much for coming. I'm at JBaruch on Twitter. Hashtag DPE for developer productivity engineering. This is JConf.Dev, so give Vincent the organizer some love on Twitter, please. And speaking.jbaruch, this is also where the QR code will take you for the links, the video, the slides, and everything else that I didn't have time to mention about developer productivity engineering. Thank you. I have no idea where the closing is. I guess, I don't, it's here. Okay, so I stand between you and going home. How sweet. All right. No time for questions because we're going home apparently. Thank you. Okay, Victor had one job to turn off the video. All right.